All right, ladies and gentlemen, let's go ahead and jump into reviewing Chapter 8. Chapter 8 was working with logarithms and exponential form. Let's see if we can remember number 1. Change the following to exponential form. I'm going to give a road to excellence if you can remember this. I do have some donuts to give away today when I pick road to excellence. So for more opportunities to win, raise your hand if you can tell me, what would this be in exponential form? Molly. So there's a specific number that's the base. That's going to be holding up another number. 2. Good. 2 to the 10 equals x. The base is the subscript of the log. And then that's going to be holding up the other number. And then it's going to equal that other value. Nice job, Molly. Number 2, can you go backwards? Can you take something in exponent form and change it to log form? Someone raise their hand and tell me what would this one be. Emily. Perfect. Log base x of n equals m. Awesome. Okay, using that conversion, we can evaluate logs. So number 3, if I'm asking 2 raised to, I'll just go ahead and call this x because that's what I'm solving for. If I ask 2 raised to what power equals 32, I'm really looking for 32 is 2 to a certain power. Does anybody know what it is?
6.
2 to the 6th is 64, I believe. So it's 1 less than that.
5.
2 to the 5th. Good. So the value of this log is 5. Now, here's the beauty of the final. You can use your calculator on the whole thing. So do you guys remember how to evaluate a log using your calculator? This would be a helpful thing to remember, because then you wouldn't technically have to go through that work. Nice, Ezra. It's alpha window. So if you didn't remember that, I would write that down. That's a really good thing to remember for the final. Alpha window, option number 5. And if I'm asking what is log base 2 of 32, my calculator will tell me it is 5. So you can confirm that.
Does it work with exponents too? Or not exponents?
You could take
with variable.
with when x is the variable.
Yeah.
You have to use a different method to solve, but then you would like take the 5th root, I think is what you're thinking.
Okay.
Okay, number 4. Number 4, try to do it by hand first. See if you can figure it out mentally, and then check it on your calculator. All right, if you got this one, the answer should be 3. 5 to the 3rd power is equal to 125. On to number 5. Number 5, if I was asking 2 raised to what power equals 1/8? I know you can do this on your calculator, but actually remembering what this is equal to will help us on different places of the final. What if I look at 8? 8 is really 2 cubed. So I can call this 1 over 2 cubed. The rule that I really want you guys to recall is what type of exponent puts a number under 1? A negative. Good. So this could be written as 2 to the negative 3. So if I just recall that, I don't have to jump to my calculator. What's the value of x? Negative 3. Perfect. So log base 2 of 1/8 is negative 3. And this rule, it shows up on the final. It's a good one to recall. If a base has a negative exponent, you put it under 1. All right, number 6. Number 6, I'm asking 27 raised to what power equals 3? I know you can solve this on your calculator, but knowing the algebra way to solve can help you in solving the equations. How could I write 27 as a base of 3? 3 raised to what power gives me 27? 3. Good. 3 to the 3rd. And I could call this 3 to the first. When you raise an exponent to an exponent, do you multiply, add, or subtract? Multiply, good. So I could just call this 3 raised to the 3 times x is equal to 3 to the first. Now, once the bases are the same, the exponents are the same. So if you guys remember when we solved equations, essentially once the two numbers holding up the exponents are the same, you could like take them away. And then we have 3x equals 1. And then we solve for x. So we would divide by 3. And I would get x is equal to 1/3. So the value of number 6 is 1/3. Number 7. Number 7, turn to your partner, the person with the most siblings. You say what you would do first, and then you guys can finish it together. Charlie, how many siblings do you have?
None.
None? Will, how about you? You have a sister, right?
Yeah, I have one.
One sister. Okay. I have a brother and a sister, so I will take the lead on this. If we're asking 7 raised to what power equals 1/7? Do you guys remember how we could write 1/7 as just 7 to an exponent? You guys are on mute. I don't know if you're trying to say it. Yeah, nice, Charlie. 7 to the -1 is the same as 1/7. So this answer is just -1. All right, guys, the answer for that one is -1. Any questions on that so far? Yeah.
What was the formula that you gave us to do these problems? There was some sort of
Formula.
it was like A, B. Yeah.
Oh, the, like how to convert from exponent form to log form?
Yeah.
If you have a to the x equals b, this is interchangeable with log base a of b equals x. That is like a really, really, really good thing to memorize for the final. It will definitely show up. So thank you for asking on that. To number, is that what you were asking, Leanna?
Yeah.
All right, number 8. 4 raised to what power equals 1? 0, nice. Any number to the 0 power is equal to 1. Nice job. Okay, now after we reviewed some of those rules, that can help us for solving various equations. So let's jump to number 9. It says solve for each of the following, leave your answer in exact, that means don't round, form. So number 9, using that rule that we just reviewed, what would be the base of this law? 5, good, raised to 0 equals, nice. We just go kind of around the world. And 5 to the 0 power is equal to 1, good. And now I can go ahead and solve. So I'm going to add 3 to both sides, giving me 4 is equal to 10 times x. What undoes multiplication? Division. So we're going to divide both sides by 10. And then it said leave your answer in exact form, so I don't want to do any rounding. But 4/10, I know I can reduce. What goes into 4 and into 10? 2, good. So this is going to be an answer of 2/5. And then do you guys remember you could check this answer to see does it work? That might be helpful if this multiple is multiple choice, which I told you it is. You could actually go ahead and just check to see, hey, is one of the answers that I got truly correct? I press alpha window, option number 5, and I'm asking, is log base 5 of 10 times my answer, which alpha y equals numerator over denominator. Oops, I didn't do that right. There we go. I got to multiply 10 by that. Somebody taught me a trick to enter in a fraction. I think it's alpha link. Yeah, guys, that's so much faster. If you press alpha and the number right next to it, it quickly pops up the fraction bar. Alpha link, the number right next to it. So if I do 10 times 2/5, and I see is that number -3 truly equal to 0? It is. So I know I haven't made any mistakes, and I got that answer right. All right, on to the next one. Number 10. There's no base there. What's the base understood to be? 10. Nice. Let's go ahead and write it in. Now we can go ahead and use that rule. So it would be 10 to the third power is equal to x over 5. 10 to the third power is 1 with 3 zeros, also known as 1,000. And then x has been divided by 5. What undoes division? Multiplication. Good. So we're going to multiply by 5, multiply by 5, and we have 5,000 is equal to x. And those are the types of questions you could anticipate to be from chapter 8. Last chapter to review for the final is chapter 9. Chapter 9, find the vertical asymptotes, the horizontal asymptotes, and the holes of each function and sketch the graph. Okay, one thing that would probably be good to review, because this is one that came up a lot in chapter 9, is what are the 3 cases of where you could get a horizontal asymptote. So let's go ahead and review over here. Case number 1. If the degree of the numerator is less than that of the denominator, an example of this would look like y is equal to 2x over 3x squared. The degree of the numerator would be 1. The degree of the denominator would be 2. Then, do you guys remember what the horizontal asymptote is located at?
0.
Yes, good. Y equals 0. Nice. Case number 2. If the degree of the numerator is greater than that of the denominator, example, if I have something like y is equal to 2x squared over 3x, then, do you guys remember what the horizontal asymptote is? None. Awesome. You guys have good memories. And then lastly, case number 3. Case number 3. If the degree of the numerator is equal to that of the denominator, an example of this would look like y is equal to 2x over 3x. Then your horizontal asymptote is going to be at y equals what? How about for this example? We do have to do something with the 2 and the 3. Yeah, it's just you put it right over each other, 2 over 3. So for any case, it's actually y equals, we say the ratio of the leading coefficients, a over b. And that would be that third and final case. Where do the vertical asymptotes and the holes come from? So I'll go ahead and say the vertical asymptotes and the holes. You guys remember where those come from in the problem? The bottom, good. It's the x value that makes the denominator equal 0. Those are where your holes and your VAs come from. And then let's go ahead and start the problem and see what we can remember with the holes in the vertical asymptotes. Number 11, what do you think the first step would be to do? Factor, good. So if I factor this denominator, the numerator is x plus 2. If I factor the denominator, the last term is negative. So am I going to have the same signs or different signs? Different, good. X times x gives me x squared. 2 times 1 would give me 2. Am I going to want to make the 2 positive or negative? Positive, good. So it'll add up to be a 1x. Now I have 2 points of discontinuity. When x is equal to 1, that would make the denominator equal 0. And when x is equal to negative 2, that would make the denominator equal 0. Raise your hand if you can tell me, is x equals 1 a vertical asymptote or a hole? Christian?
Vertical.
Awesome. How'd you remember that?
Because I put from the numerator, those people out.
Nice. X plus 2 is going to cancel, which means x equals -2 is going to be a whole. Awesome. So I'm going to go ahead and draw the vertical asymptote at x equals 1. The whole, Christian told me that -2, that one is where the hole is going to lie. Can someone else raise their hand and tell me how do we find the y coordinate of the hole? Liana?
Wouldn't you just, plug in 2 for like x in like whatever is left? So it would be
What would be left in the numerator? 1. Good. So I'm going to plug in exactly as Liana said, x into 1 over whatever's left, 1 over x minus 1. So I'm going to put -2 in for x, and that'll be 1 over -2 minus 1, which if I simplify that, that would be -2, oops, -1/3. Nice. All right, so now I'm going to go ahead and I'm going to plot these things. I'm going to plot a hole at the location -2, -1/3, like that. I'm going to graph a vertical asymptote that goes up and down through the x coordinate of 1. And looking back at the original function, can someone raise their hand and tell me what would be the horizontal asymptote of this graph? Cynthia?
0.
Nice. Y equals 0 because the degree of the numerator is less than that of the denominator. Awesome. So I'm going to go ahead and I'm going to graph that horizontal line. Now, the last thing I have to do is see where's this graph sketch going to be? Is it going to be up here? Is it going to be down here? Is it going to be up here? Is it going to be down here? How do I do that? How do I figure out where it's going to be? Emily? Create a chart. Awesome. I'm going to use the reduced function, 1 over x minus 1. And then how do I know there's an infinite numbers to put in the chart? How do I know which ones to put? Liana?
So you put the VA, one point to the left and 1 point to the right.
Awesome. 1 point to the left and 1 point to the right. So I'm going to plug in 0 in my chart, and I'm going to plug in 2 into my chart. And if I plug in 0, I have 1 over 0 minus 1. 1 over -1 is -1. So I'm going to have the point 0, -1. And what that allows me to do is I know my graph's going to go through this point, and it always gets close to the asymptotes but doesn't reach them. Has a hole there, but then it gets close to that asymptote but doesn't reach it. And then when I plug in 2, I have 1 over 2 minus 1. That's 1 over 1, which is 1. So I have the point 2, 1. And then I know it gets close to the asymptote but doesn't reach it. Gets close to the asymptote but doesn't reach it. All right, that was a quick review. I'm going to give you guys a few minutes. See if you can do number 12 all on your own, and then we'll check it.
Ms. Prempis,
Yeah.
what day is our final?
Your final is next Thursday because you guys are 5th period. So they'll be the first final on Thursday. All right, guys, go ahead and take a look. You should have found a hole at the location 1, 3. There's no vertical asymptote because nothing's left in the bottom. There's no horizontal asymptote, God bless you, because the degree of the numerator is bigger than that of the denominator. You could have used a table to help you locate points on your graph. Did anybody remember the trick that you can use if you just have a hole with the equation that's left? Ezra?
Just left and right of the hole.
Left and right of the hole, which is good. But do you remember like how I could use this? This is what's left. Well, Ezra?
You can just use y equals mx plus b.
Awesome. We could use mx plus b. We could use the fact that the slope is 1, the y-intercept is 2. And then we have that y-intercept of 2. We go up 1, right 1, up 1, right 1, and we can see the graph is going to take on that shape. Or you could use a table and just know that there's no limit the graph is reaching. There's no vertical asymptote, horizontal asymptote, so it takes on the shape of a line. Last thing I want to ask you, because I'll just let you guys know this is on the final. What if I give you the equation in factored form? If you're given y is equal to like x plus 1 over quantity x plus 1 times x plus 2. And I ask you, what is the horizontal asymptote? Sergio, what do you think?
0.
0. Sergio, how do you know it was 0?
There's 2 x's, so it's gonna be x.
Awesome. This is in factored form. There's 2 x's. X times x would be an x squared. So you have to really think about this as if it was multiplied out. Technically, if you FOILed that, it would look like this. So the degree of the numerator is actually less than that of the denominator because this is given in factored form. Nice job, Sergio. All right, ladies and gentlemen, the homework in class is to finish the evens of last night's homework. And then what's due for next week would be day 2 of the homework. So you guys have this time to work. You can work with a partner. You can check your answers. I'll be walking around if you have questions. When am I available next week? In case you have a question over what you're doing. 7 to 8 a.m. I'm available Tuesday. I'm available Wednesday. Your final's on Thursday. I'll be here at 7:30. So if you have a question at 7 before the final, pop in at 7:30 and I will be here to answer. Other than that, you guys can go ahead and begin working. I'm going to pick some